Hi, this is Frank Morgigno from Applied Technologies of New York. We want to talk to you today about what goes on in the combustion process, how it affects the environment, and the technologies that are available to promote a healthier and more effective utilization of our energy resources. We're happy to have with us Mr. Alan Silver of Siemens Combustion to help answer some questions about controlling the emissions of commercial and industrial boiler systems. Alan, one of the most commonly debated issues of our time is air quality and emissions. Since our business is combustion, we're often called upon to limit what we are emitting to the atmosphere in the form of flue gases. What exactly goes on in the process of combustion, and what byproducts are emitted?
Thanks, Frank. I appreciate the question. Appreciate you having me here today. Burning natural gas and oil has become a part of our daily life. We do that in hopes that we can quench our desire and need for energy. And as a result, we will continue to burn natural gas and oil for the next several decades. Previously as an officer in the United States Navy on submarines, I found emissions to be a very important topic, especially the day after taco night. And so we'll go ahead and start and talk about some of the specific pollutants that we're concerned about when we start talking about combustion. So let's look at what the Environmental Protection Agency has to say about the National Ambient Air Quality Standards. So let's just start with what they have set as the 6 criteria that we need to monitor when we're burning natural gas, oil, coal, or other fossil fuels. Specifically, carbon monoxide, lead, ground level ozone, nitrogen dioxide, particulate matter, and sulfur dioxide. All of these pollutants are called criteria pollutants because the EPA can set a limit based upon scientific knowledge on what effects these pollutants have on human health. Obviously, the government is required to protect us from foreign enemies and domestic enemies, and oftentimes they have to protect us from ourselves. So whenever we do burn natural gas and oil and other types of fossil fuels, these particulates need to be monitored to make sure that our health and our well-being is maintained. Going back to the year 1800, there were approximately 1 billion people in the world. Fast forward now to 2019, we have 7.7 billion. In the United States alone, we went from about 5.3 million people to over 330 million people. So the quest for energy is going to continue. And until newer, more efficient fuels are developed, natural gas and oil are going to continue to be what we use for energy. So let's talk about carbon monoxide just real briefly. Breathing air with a high concentration of carbon monoxide reduces the amount of oxygen that can be transported to the bloodstream into critical organs. So in other words, with high levels of carbon monoxide in the atmosphere, typically we're more concerned about indoor activities and carbon monoxide concentrations than outdoor. A lot of health issues can result. Exceedingly high levels of CO2 can occur indoors in confined spaces. It can actually result in death. So carbon monoxide is something we have to monitor. It's something we also have to monitor when we're actually doing combustion analysis. So nitrogen dioxide. What is nitrogen dioxide? Well, breathing nitrogen dioxide in high concentrations can also irritate the human respiratory system. So people with asthma, emphysema, other types of health issues can irritate those issues and actually cause problems, long-term problems, including additional medical visits, etc. So the elderly and young people are typically more affected by nitrogen dioxide than people of our age.
So what is NOx and why is it something we want to minimize?
Well, NOx is very important for 2 reasons, really. One, NOx forms nitric acid in the atmosphere. When that happens, damage to buildings, property can occur, can also cause damage to people and health issues. So nitrous oxide, from that perspective, is very important. Nitric acid can affect the water sources in which we drink from. It can affect the runoff water, etc. And at the same time, it can form with volatile organics in sunlight and create ground level ozone. Now, ozone in the atmosphere, in the stratosphere, is a good thing. It protects us from about 95% of the ultraviolet light that we actually get from the sun. But on the ground level, it can create health issues. Again, it can cause issues with exacerbation of asthma and things like that. So ozone is a byproduct in a lot of cases of NOx, or nitrous oxide. So we have to be very careful about making sure that the area that we we live in and breathe in doesn't exceed the national air quality standards for ozone. Again, very easy how this is made. You have NOx in the atmosphere, volatile organics that come from automobiles and manufacturing facilities. Mix that with sunlight and you create ozone. Okay? Particulate matter is another one of those sources that we're very concerned about. Particulate matter contains microscopic solids or liquid droplets that if you breathe into your lungs can get into your bloodstream and cause, again, all types of medical issues. Okay? If you notice these particulate matter sizes, this would be a human hair size here. Okay, so they're very small. You have PM10, which is a 10 micron particle, and then you have PM2.5, which is a 2.5 micron particle. So these particles, if they get into your lungs and get into your bloodstream, can really create an issue. And then the fifth emission gas that we're really concerned about when burning natural gas or oil is sulfur dioxide. So sulfur dioxide, unfortunately, can really create issues with younger people and older people when it comes to their respiratory system. And it can lead also to issues associated with acid rain as well. Sulfur dioxide and water vapor can form to create sulfuric acid, lower the pH of water in your area, and, or damage buildings and property. Because this is the type of situation we don't want to get into when we're actually having to put on respiratory equipment just to walk out and go back and forth from work. This is a picture not too long ago in China. So China has an issue right now that's a little bit greater than ours. So looking at the combustion process specifically, if we look at just natural gas, just to make this very simple for people to look at. So natural gas is primarily comprised of methane. Methane is carbon and hydrogen. When you mix that with oxygen and a heat source, you create carbon dioxide and water vapor, okay, as well as the heat that you released. Carbon dioxide is known as a greenhouse gas. You hear a lot of people talking about reducing your carbon footprint. They talk about how the Earth is getting warmer and global warming is happening and the Tyrannosaurus Rex is coming back and all these other types of things. Carbon dioxide does contribute to the greenhouse effect on Earth. Without carbon dioxide, the Earth itself would be a very, very cold place to live. Scientists estimate that with no CO2 in our atmosphere, the average Earth's temperature would be about minus 18 degrees Celsius. So having carbon dioxide in the atmosphere is a good thing. Having too much can add to the global warming issues. So again, something that we don't use as an actual national air quality standard, but it's something that we're concerned about in the combustion process. Now, if for some reason we do not have enough oxygen, and we have an oxygen-deficient burner, in that case, then we could create carbon monoxide. Carbon monoxide is actually a national air quality standard, and it can be produced in the combustion process if we don't have enough air. Okay? Conditions that can cause that are, for instance, someone in the building closing the door because it's cold outside. Reducing the amount of available air to the combustion process can cause CO2 and CO to be formed and thus exceed national air quality standards in those cases. Now, when you do make carbon monoxide, they typically show themselves in the form of carbon soot, okay, or maybe smoke coming out of the smokestack in those cases. Okay. Again, back to nitrogen oxide, the two primary issues we have with that is the fact that it reacts with ammonia, moisture, and other compounds to form nitric acid vapor in the atmosphere, and then also impacts NOx on human health, include damage to lung tissue and respiratory systems. Basic NOx formation, very simple. So NOx is made when you take nitrogen, which is about 78% of the atmosphere, and oxygen is about 21% of the atmosphere, mix them together in a very high temperature. That's called the thermal NOx production. So when that happens, when the nitrogen and oxygen that are in the air naturally are heated up at very high temperatures, somewhere in the range of 2,800 degrees or higher, we form NO and NO2. Those NO and NO2 molecules now are potentially hazardous in the fact that they can combine with water vapor in the atmosphere and form nitric and nitrous acid. Those are acid rain constituents. So one of the big reasons, plus the fact that NOx can also react with volatile organics in the atmosphere and sunlight and create ground level ozone. So it's kind of a double whammy when you start looking at that respect. So that's the big reason why we want to eliminate NOx in those cases.
Thank you, Alan. For more information on low NOx technologies or any other boiler room related solution, please visit our website at www.atiofny.com. Thank you. Thanks so much, Alan.
Thanks, Frank. I appreciate your time. Look forward to seeing you guys again.
Absolutely.
Thanks a lot.